Alright, welcome back. So part 2 of making this system design document is to actually finalize what type of stuff we're going to be using, and then from there we're going to follow the same ruling and the same patterning. So one of the most important thing is we already defined quite a lot on what type of mechanics we're going to have, right? We also abstracted them. We also systemized them in a way where we know exactly which one is going where. We also brainstormed a few ideas on, and then we also prioritized what we're going to do, which we kind of did it over here, where we prioritized exactly which one we're going to do. Now we can do it for the other ones, but let's start making some progress before we go for the other stuff. And then after that, we're going to start building it. So the last part is we're actually going to do a little bit more of first 5 steps, but how we're going to do is we're just going to finalize it, and then after that we're going to start building it. So we notice the characters have certain types of pieces that they have that considers it part of a character. Like for example, a character will have animation, movement, interaction, inventory, and equipment. Now if we were to talk about enemies would technically be a type of character, right? And then we could say the enemies is a type of character in the game which does these little extra stuff. Now when you see parts of it, you'll notice that there is a few differences. Like for example, not all characters are considered having equipments or inventories, but all enemies are considered characters. So that's a difference between inheritance and composition. So a one-on-one on inheritance and composition. Basically, an inheritance and a composition is basically a relationship type between is-a and a has-a. So for example over here, if you're an inheritance, you have a car type example, which basically has either a coupe, a sedan, or SUV. So you have a car that's either a 2-door, a 4-door, or this hybrid type car, which is partly truckish. And that would be inheritance because you have either a 2-door or a 4-door, but it's still considered a car. So it is a car, right? Now, as for composition, you can have a car and it's built up of pieces. So for example, a car has an engine, a car has windows, doors, and hood. So in the same way, when we look at our character and our enemies, we could say an enemies is a type of character, so it inherits from the character, and then the character has pieces that make it a character. For example, it has a moving component, it has an animation, it has inventory, equipment, and interaction. So our enemies would have some of these things. Maybe we don't want it to have it, we can change and move it. It's up to us, but it is a character, so it does consider itself as a character. Now if we had an NPC over here, which I didn't write it down, but if we have an NPC, alright, just made a little difference where I changed it to saying others instead of enemy. This way we can have different types of characters. We can have like animals, we can have enemies, we can have NPCs, we can have nature as a character, and we can have players as characters. Now if you ask me what trap or nature would be as a character, I'll give you some ideas, but for now just think of it like that. Alright, so the next thing you'll learn is the difference between architectural patterns and programming patterns. Architectural patterns are basically how you want to structure your code, and programming patterns are basically little things that you want to do inside the code to make it look a bit cleaner or more consistent. So that's the main difference between these two, and we're going to be choosing what we want. There's no right answer. There's always something that's better in certain use case scenarios. So in our case, we're going to be going through some of these and basically deciding how we build our game. So going back to our character, we noticed that a character has a few main components that they have. And since we said that our character will be using composition, we're going to have to build it out just a little bit more detailed. So in order to build it out detailed, we just have to give it a simple UML diagram. And the way to do that is we're going to have a character with the basic component inside the character. We just have to build out those components. Now here's the thing, that movement is going to be used in your enemies too, or it's going to be used in the NPC, or it's going to be used somewhere else. So these are very recyclable items. And now the main thing is you want to understand is we are using command patterns. So command patterns are basically the function or the object you're going to be using follows a certain command, or it just does one thing. Like for example, you have a function that's called move forward, or you have a function that's called move backwards. You have a function that's called duck, you have a function called that's jump. So what this does is basically it helps you loosely couple up code. So for example, in the jump function that we have here, we have two different ways where we could either use physics, where it just adds a force on the top and it just pushes your guy up into the air and then lets the physics handle the rest of the stuff, or the other way where you just translate your guy up a little bit and then you simulate gravity later on. So as you can see, there is two types of way of jumping it. And the beauty of how we're doing the command pattern is, let's say for example you decided to change it all. Changing the jump function will not ruin the rest of the code. For example, you wrote something weird inside the jump function and it caused some type of error, and you basically want to decode or debug the error. Then you try using the different types of commands. So for example, you tried moving forward, backwards, left, right, nothing happened, duck, nothing happened. The moment you press jump, something happened. Then you can easily go into the code and fix the jump command or fix the command function, and that will help fix the bug. So the beauty of command functions is you do decouple your code. They're not very much stuck to each other, and if you wanted to change a specific object or a specific command, you could change it very easily. So that really saves you time. Once you're done with doing something like this in terms of a character, the final step actually is going to be building the objects inside your game. And the way you build is you have to give a specific type of ruling set. So the last thing you're actually going to be doing is giving a naming system. Now this might be the hardest because nobody can agree to what a correct naming system is going to be, but if you do decide to name it a specific thing, make sure you keep it in that consistent name, and this way it kind of helps basically regulate the way the game works and how you're gonna basically, you know, structure your game. Now for some people it's pretty much exactly how you name other types of programs. Like for example, in the MVC you can have a model, you can have a view and a controller, so you could just call them like for example the UI controller. You can have that, you can have the enemy model, you can have the character model, and then you could just have the view as the UI itself. Now it's free for all at this point, whatever you like to name it. In our case, what I'm going to be doing is I'm going to name all the components as handlers. So like physics handler, animation handler, movement handler, interaction handler, equipment handler, or something. I'm going to name the main composition elements, so like characters, I'm going to name them as controllers. So character controller, database controller, vehicle controller, other controller, so enemy controller, UI controller, right? So we're going to be naming it like that, and then after that the only thing left is just connecting it in a system. Now that's going to be the final part, where once we actually build it out. So in order to do that, we're actually just going to be using the most simple pattern, which is either the observer or the event architecture. And how does that look like? So we're basically going to be doing something like this. This is going to be the main event system, and events are basically going to be like an observer pattern where we add a listener. Listener is going to be a new person who listens in, and we have a function that's called notify, and we also have a list of all these listeners. Now how does this even work? Basically you subscribe to a notification system on the event, and whenever a certain event happens, it notifies the subscribers. You'd have a bunch of listeners. So for example, you'd have like a movement or like a character or anything. A listener would be any of these components or objects who ask for the event that they want to subscribe to this specific event. Now the event could be something specific, like for example, on enter private island event, or on enter Grandmaster's house event. So you make your own event based on the specific subsequence that you want. So if you enter the Grandmaster's house, it's going to be called on enter Grandmaster house event, just as a naming standard. All right, and then you expect like certain things to happen when you enter. Like for example, the audio starts becoming a different song, the visuals UI changes, or let's say it removes it because you're in safe area or something, or he's like the enemy Grandmaster, so your combat mode starts. And then for a character, you stop sneaking because now you're caught or something. So as you can see, that's what it wants to do when it enters the Grandmaster home. So the moment it subscribes into it, it waits for the event to get, or it waits for the event to trigger. So the moment you as a character trigger or go into the Grandmaster's house, then what happens is it does a notify, which is this function. You go through all the listeners that are subscribed to this event, and you just tell them that you triggered the event, and that's it. And then from there, the triggered event in each of these functions will, or each of these components will do what it was supposed to do. In the audio, it's going to now say you triggered this event, we're going to play this song. So from there, it basically loosely couples code. You have the commands sitting in the components. The events are the ones that are going to fire it out. And that's basically it for what we do. So with that all done, now you actually built your own system. You built your structure. You built exactly what you wanted to do in terms of brainstorming. You also built out exactly how you want to basically restructure it, how you're going to edit it, how you're going to build each step, how if you do make a mistake you can remove the mistake and change it, how you're actually going to build the connections between them, the relationships between these objects, and also how you're even going to build the program in the first place. Now with all this in mind, again, I did not flesh out any of this. This is just an example for you guys. In the next episode, we're going to start building the character, and then after we're done building it, we're going to start building all the other ones. And as we keep on building it, you'll realize we're going to be using the exact same patterns and recipes that we have built for ourselves. Now, why is this important? The very simple reason is we have a consistency and we have our own milestones that we made for ourselves. So now as a project manager, since you are going to be wearing many hats, you're not going to reach the whole lazy zone, or the fact that, you know, you're going to get into burnout, or you're even going to get into some kind of stress, because you have it all written down in structure. Now, what you're going to do next is you're actually going to build out one whole finalized recipe for one object. So this is why we did the character. This is the fastest way to get something built out. Then once we get the character done, we're going to build something else. For example, let's just say the database or the UI, or we're going to build something a little bit more intricate. And then once we do that, we have a recipe of consistency where we're going to basically replicate the exact same recipe for our database, our transportation, our UI, characters, and in the future we'll have quest systems and all that, or even the networking. So the main thing is, once you build it in this specific structure and sequence, then you can copy paste it to other places, and then you can move from there and you can edit it, and you basically have a recipe for success. Now this is the most basic way I can tell you. Anything more requires me like hours and hours of teaching, or even going back into the books, getting some more information and getting more stuff out of it. But from here, you can realize that how, from an idea that we had as a conceptualization idea that we had, we structured it into actual milestones that we, as, or anybody who's a little bit technical, can actually build a game from scratch. And then from there, this is the recipe for success. And there are different ways of doing this. This isn't the only way. As I told you, you have many different options, many different ways of doing this. This is one of the ways that is very easy and very doable for anybody, from basically beginners all the way to expert. And it is a very simple blueprint that you can start with. So with that, I will leave you guys. I hope you guys did like this episode. Let me know if I was either too fast or I didn't give too much explanation. I'll always fix it up. But other than that, the next episode, we're going to be building our character controller. And then we're also going to be building some of the components, just the basic ones. And then we're going to show you exactly how it works. So with that in mind, I will see you guys next time. All right, goodbye.